My guest today is David Dilley.
Well, good afternoon or good day, world, and Tom Nelson. We have another great podcast for you today. It's going to be in 4 parts. And first of all, I'm going to give you a little bit of my credentials. And I'm Professor David Dilley. I'm a former meteorologist with NOAA, National Weather Service, and also in the United States Air Force. Currently, I'm a senior researcher, meteorologist, climatologist, Global Weather Oscillations Incorporated. 50 years of experience. And a working partner of the International Hurricane Protection Association. Here at GWO, I created what I call ClimatePulse Technology, based on proven science. What it is, it's electromagnetic interactions of the Earth, Moon, Sun. Here at GWO, specialize in hurricane landfall predictions as analyzed and based on gravitational cycles. Also, El Nino predictions out 2 years in advance using the same technology, and climate change research and predictions. I do have a peer-reviewed ebook that was put out around 2009 and called Earth's Natural Climate Pulse. And ebook updates. I've updated this tremendously since that time by doing video podcasts like with Tom Nelson. And we're going to have 4 of these right on our website, www.globalweathercycles.com and globalweatheroscillations.com, and also Tom Nelson's podcast. Okay, here is why we're here today on the podcast. Well, we've seen this in the news. Earth's global temperatures, 2024 and into 2024, but during the year 2023. Warmest on record, and we're told it will continue. Well, will carbon dioxide and global warming end the world in 12 years? We were told this way back about 5 years ago, 6 years ago. So we only have 7 years left to go, according to them. The world will be ended by 2031. Will it? Let's see. Well, let's gather our thoughts. Understanding global warming. And even my little dog understands, because animals and humans have instincts. And my little dog here says, my instincts say, use common sense. And that is what we're going to do today. Common sense. Okay, 4 parts to the podcast. Part 1, climate change cycles. Going to take a look at the warmest year on record, 2023 into 2024. And this is as recorded by modern instruments since 1978. Everyone should understand this is the first time we've had a global warming cycle with instruments. Never before in the history of the Earth has this happened. And we have never had instruments recording an event going into global cooling. So there's a lot we have to put into it. And this is why we hear people talk about the current global warming cycle from 1850 until now, but they don't go beyond 1850 prior to that because we didn't have instruments. So according to a lot of people, we have only had one global warming cycle and that's it. And I'm going to show you that is totally untrue. Earth's natural climate pulse. First, we have to understand history to know the future. Humans and animals require a good night's sleep, or we do not function well. Well, the Earth is the same way. It requires periods of long rest or periods of activity, or it does not function well. And what would cause it? ClimatePulse technology. We're going to look at the interactions between the Earth, Moon, Sun. It's proven science. Earth, Moon, Sun interactions. Well, the cycles, the Earth, here's the Earth over here, has a track around the sun, an elliptical path where it swings in close to the sun in January and further out in July. And this elliptical path changes over time, over a 120,000-year cycle as it goes around. Currently, the cycle is where the elliptical path is in closer to the Earth, not as stretched out, but during glacial periods, it becomes more stretched out. So we're further away from the sun, less solar radiation, insolation, and also there's a cycle in the axis tilt of the Earth every 41,000 years. Changes from 22.1 degrees tilt to 24.5 degrees tilt. And what that does, that changes the amount of solar insolation coming in to much of the Earth. And this is what happens. Here's our cycle set up by the long-term cycle. Back 425,000 years ago, we had a very warm interglacial period. Then we went into a very long sleep. Ice Age. Came out of that 325,000 years ago. Then back into Ice Age, warm, Ice Age, warm, then a big long Ice Age. And here we are, about 8 to 10,000 years ago, we came out of the Ice Age, and this is where we are now. We are supposed to be warm, not cold. And as we came out of the Ice Age, 8 to 10,000 years ago, as denoted by the blue, that's cold, that was the Ice Age, it warmed up. 7 to 8,000 years ago, it was extremely warm, much warmer than today. Even had less ice in the Arctic than today. Since then, we've had 1,200-year cycles where we cool down, warm up, cool down, warm up. And you can see overall, we have been cooling down during the past 7,000 years. And here we are over on the right. We are supposed to be warm now. We are in a warm 1,200-year cycle. Well, humans also sometimes require a short nap in the afternoon. Just a little rest so we can function better the rest of the day. Well, the Earth also requires short naps, or it does not function well. And what we have here is a lunar solar precession. It controls El Nino events, hurricane cycles, climate cycles, the shorter climate cycles. And again, here is the moon. And what we see is it also has an elliptical path around the Earth, just like the Earth around the sun. Once a month, it will swing out further away from the Earth. That's called an apogee, greatest distance from the Earth, and less gravitational pull on the Earth, lower tides in the ocean. And then, once a month, and on other cycles also, it will come in closer to the Earth. This is called a perigee, close approach to the Earth. The gravitational pull increases by 30 to 40%. That's quite a bit. So we have higher tides once a month. Well, at times, the Earth, Moon, and Sun all become in alignment with the Moon at perigee. This is called a perigee syzygy. This occurs about once a year, and then on longer cycles also. When this occurs, the gravitational pull on Earth is actually up to a little bit more. It increases up to 44 to 47% above a regular moon gravitational tug. That's a big one. And at times, that's why lots of times you hear in the news about once a month, well, there's coastal flooding, and there isn't even a storm in sight. That's due to the perigee syzygy. And one thing that happens, this is a 4-year cycle, the sun moved from the southern latitude. This is the high energy, strong gravitational cycles, the strong ones that occur every once a month. They'll move from below the equator to above the equator, and 4 years later back down. And that causes tremendous tug on the oceans and atmosphere. It causes like a plunger. When this happens, the atmosphere and oceans expand and contract. On strong cycles, the outer core of the Earth can bulge as much as 1.5 kilometers. More earthquakes or volcanic activity. This is how powerful the moon is. Ocean and atmospheric tides. We have the 12-hour ocean tides. Then we have other ones that are showing you the 4-year cycles out to 72-year cycles, and we're going to be talking about the 230-year cycles of strong atmospheric gravitational cycles. The 18-year cycle that I showed you, where the strong perigee, syzygy cycles will be up in the northern latitude, up as high as 28 degrees above the equator in relation to the equator, 28 degrees latitude. Then it'll go down to the equator, and 4 years later, it'll be in the southern hemisphere at high latitude. Then 4 years later, it'll be back to the northern hemisphere, southern hemisphere, northern hemisphere. And again, you can see the greatest elevation in the sky in relation to the equator occurs every 18 years. The big cycle every 18 years. So we're seeing 4-year cycles and 18-year cycles here. And the one going out 1,200 years looks exactly the same. Instead of 18-year cycles, now we're talking about a 220-year cycle, 240-year, 240, and 230. They look the same going out in time. Now, a lot of people do not understand it, but we have had 6 global warming cycles during the past 1,200 years, not just the current cycle. There have been global warming cycles prior to 1850. My cycle number 1 was peaked out at year 850 AD. Then there's number 2, 3, 4, 5, and today's number 6. And we're about to go into global cooling. Now, the purple line that I put on here, that's the gravitational cycles. They line up with the global warming cycles. And now here we are, peaked out on the gravitational cycles, and it's ready to go down. Part 2, climate change, warmest year on record, as recorded by modern instruments. So let's take a good close look at it. And here it is, 2023 to 2024, warmest on record, and they say it will continue. Well, the mean global temperatures, the way it is recorded is they take ocean and land temperatures and add them together and get a mean value, and then they have a deviation from the mean for the areas. What does it all mean? Well, the oceans cover 71% of the Earth's surface. And on this graphic here, the blue is below normal, colder than normal water temperatures. The yellow, orange, and red, warmer than normal. And the red is much warmer than normal. And on this one, this was November of 2023, you can see some deep red to the west of South America along the equator. That was due to a El Nino event. So you can see taking 71% of the Earth's surface as being warm, that's going to mean a lot to global warming. This is the actual depiction of what was really occurring at that time. There's the oceans in the kind of red, light red, all being pretty much warm, some small pockets of cool ocean. But then on land, Yes, we had some warm areas in eastern Canada and east and northeastern United States, but we also had an area of cold from the Gulf of Mexico up through western Canada, up into Alaska, then northern Greenland. Scandinavia had one of its coldest and snowiest winters in over 30 years. And then Siberia, and then we saw a few other cold pockets around the globe. So not every area was warm, even though it was the warmest year on record. And when I showed you the graphic where they take the ocean area, 71% of the Earth's surface, and the land areas, add it together and take a mean value. What that does, it washes out what is really occurring in the Antarctic. January 24, coldest weather on record in much of the Antarctic. The dark blue is all-time record coldness. So is the Earth really that cold, that warm? Well, let's take a look at it all. Part 3, update. Ocean temperatures. What's going to happen with the temperatures in the ocean? Because that is in the formula for determining the Earth's temperature. As I indicated earlier, the year 2023 into early part of 2024 had what we call a El Nino event. This is when the ocean water temperatures, my cursor's right there on the northern part of South America. This is the equator in the Pacific. During an El Nino, that area warms up. The ocean water temperatures warm up to be very warm, much above normal. That's depicted in the orange and red. And of course, that was added into the formula to determine 2023 being the warmest year on record. Well, what's happening now? We're having a big change. The El Nino is giving way to what we call a La Nina. That's the complete opposite of an El Nino. Down on the right-hand graphic, there is South America. Now, along the equator, from June through the next year or two, we're going to see colder than normal temperatures. You add that into the formula to determine the Earth's surface, and that's going to make a big change. So let's take a look at the ocean water temperatures in 2024. All around the globe, you can see warmer than normal. Very warm, very warm. Well, we're going into the La Nina. In the middle to late 2024, that's going to cool down much of the Pacific Ocean along the equator. Then the rest of the Pacific has what we call a decadal oscillation, PDO, temperature cycle. And this graphic goes back to the year 1500. And what we see is around 1540 was the peak where the ocean water temperatures in the Pacific warmed up, a warm cycle. Then cooled down, warmed up on about a 30-year cycle. Cooled down, warmed up, right across the board, you can see the warm cycles. And we came into a warm Pacific cycle in 1981. We're into about the 42nd year. That's happened twice before, 42 years. So the Pacific is now due to go into a cool phase. A cool phase. This will be beginning this year as the La Nina strengthens. And this is all the information, Pacific oscillation, just to show that I'm not making anything up. You can research all the material. So this is what we're going to see in the year 2024, latter part of this year, late this year. There's going to be 3 cooling spots in the Pacific. And now much of the Pacific is going to be colder than normal. Much of it. What about the Atlantic? Well, the Atlantic has a similar type of warm and cold phase. On the left of the graphic, the red, that's when the Atlantic Ocean is above normal water temperatures, above normal. And that was year 1870 to 1900, lasted about 30 years. Then it cooled down. Then we had another cycle, warm cycle, lasted 32 years, cooled down. And now we're in another cycle, which will last about 31 years. 31 years. That will take us out to the year 2030. So in 2030, the Atlantic Ocean is going to be right near normal or below normal, and it's going to be below normal for about the next 65 years. So now, as we look at the ocean temperatures around the world, we've already shown you that the Pacific Ocean will be cooling down. Here's the Atlantic Ocean. That will be cooling down 2030 to the year 2074. Much of the Atlantic Ocean will be colder than normal. So, what is NOAA and rest of the organizations going to do using 71% of the world's coverage added in? You no longer have global warming. Global warming would be dead and gone by 2030. Part 4, the final part, climate change. What is causing a record cold in the high Arctic? Well, global warming cycles begin in the Arctic. They come every 200, 230 years. And also in the Antarctic. And as the Arctic and Antarctic warm up, there's less real cold air to filter down into the mid-latitudes. Thus, it warms up the mid-latitudes. And this is what's happened really from about year 2000, especially up through 2023, warmed up the mid-latitudes. Well, global warming begins in the Arctic and Antarctic. Global cooling also begins in the Arctic and Antarctic. Up in the Arctic, 2022 and 2023, this is the high Arctic, coldest spring and summers on record, since records have been kept from 1958. Coldest on record. Down in the Arctic, 2021 was the coldest winter on record in the Antarctic. And also I showed you a depiction where they're now receiving record cold again. So both are cooling down. As they cool down, there will be more cold air available to filter down into the mid-latitudes, and that will end global warming. So why is the high Arctic cooling down? Well, one thing to look at is the June solstice. This is the summer solstice. I talked to the Earth, and during the summer, the Arctic is tilted towards the sun. 24 hours of sunlight. 24 hours. So they get a lot of solar insolation during the summer. And this is the weakening trend of solar cycles and solar insolation since 1978. We had a strong cycle around, it ended in 1982. The next strong cycle for a strong solar insolation ended in 1992. Next one is in 2002. And next one, 2014. And the next one will be ending this year, 2024. And you can see how the strong solar insolation cycles have declined since 1978. Very strong through 2002. And then they started to weaken. And in 2014, it's a shorter cycle, smaller cycle. And that's one reason the high Arctic is beginning to cool down. And now we're over here on the right. We're even on a weaker cycle. This is 2024 right now. The solar cycle will likely be coming off its peak, and it'll even be getting colder in the northern part of the Arctic. This is a depiction from NOAA, a little bit harder to read, but you can see the light orange. This is the solar insolation cycles. This is back around 1610. But over on the right, wanted to show you on the right, this is a strong solar insolation cycle in this boxed in area right here. The dark red is what NOAA showed as this is our global warming cycle from 1960 up to now. It's conforms, it's occurred with a strong solar insolation cycle. Well, if we go back 170 years, we also had a strong solar insolation cycle, 1725 to 1790, and we had a global warming cycle. Well, with this one ending in 2024, becoming weaker and weaker and weaker, we go out 170 years into the future, that will be the next global warming cycle, number 7, in 2194. So between the year 2030 to 2190 or so, it's going to be cold. Now, let's look at the temperatures in the high Arctic. I keep talking about the temperatures in the high Arctic. The blue line is the mean or average temperature, monthly temperature in the high Arctic. This goes back to 1958 through 2002. The blue line is the mean. Orange line is the recorded temperature for that year. Well, in 2022 and 2023, it was warmer than normal during the winter months in the high Arctic. But then when we come summer, this is when we have the solar insolation, stronger solar insolation, because winter is 24 hours of darkness. Summer, you get 24 hours of light, sunlight. Well, during the 2-year period, 2022 and 2023, from about May into August, you can see the temperatures are below normal. That was 2 years in a row. This had never happened before since records began in 1958. Now, currently, up to May 5th, this is the temperatures in the high Arctic, again, warm in the winter. And here we are in May. They're actually still running a little bit above normal, warmer than normal. And why is this? Well, one reason is our solar insolation cycles, they go up and down, up and down. You probably have a 2-year peak, and it probably peaked out a little bit this year. Then the latter part of this year, it will drop off again and go into the long-term less solar radiation. And also a combination of the very warm El Nino that we had probably pushed a little bit more warm air up into the higher latitudes. So we're going to monitor this. I expect that later on in the summer, it'll go below normal. And next year, it'll be back with no El Nino. It'll be below normal temperatures in the high Arctic next winter, probably even colder than the prior 2 years. And the ice extent, everyone says the ice is melting. It's going to be gone. And Al Gore said it would be gone by 2016 to 2021, somewhere in there. Well, let's look at the ice extent in the Arctic. The gray line is the mean or the median of the ice from 1981 to 2010. And you can see over on the left, that black line is, the blue line, green. Let's go to the green line. That's 2022 or so. We've been running, yes, below normal ice in the Arctic. But look at the this year. This is the black line this year. And we're coming down. Here's May. Look at where we are in May this year. This is the mean, the gray, and this is this year. It is almost normal. The ice is building in the Arctic. And we're not being told about that. And what is going on in the Antarctic? All we hear about is the ice is melting. But as I showed you, Antarctic, it was January of 2024, record cold across the whole Antarctic. But the ice is melting. Well, here is a picture of the Antarctic. This bluish, light blue area, that's the ice dome in the Antarctic where it's been running very cold to colder than normal for several years now, and especially during the past year. Now, the reason they say it's warm in the Antarctic and the ice is melting, it's in the area where I have circled in red. That is running warmer than normal. And why? It's not because of global warming, but if we look at all these little white dots everywhere, volcanic activity. And it's even occurring out in the ocean underneath the ice. The ice is melting from the bottom up, not the top down. And the rest of the Antarctic, the ice is building on the top. It's increasing. So we're getting a false narrative. The Antarctic is not melting away due to global warming, only due to volcanic activity. Combination of decreased solar insolation cycle also, and the ClimatePulse electromagnetic gravitational cycles. And I want to show you the electromagnetic gravitational cycle. This is a graphic that I did up, taken the red line is the Earth's temperatures. These are the global warming cycles that I have in red here, shaded in red, the 6 global warming cycles. And the yellow is the gravitational cycles. And this is a kind of a long-term mean of the strongest gravitational cycles, the syzygy cycles, where it's the alignment of the Earth, Moon, Sun, very strong cycles. Well, up on top here, where I've got the circle, that's very strong cycles, high in declination is what we call it in regards to the equator. And during that period, when it's high like that, we're in a global cooling cycle. But then, when the cycle comes down and it's lower in the declinations in the sky, median, we're in a global warming cycle. You can see this one lasted all the way across. Then when you came out of that cycle, drastic cold cooling. And then we came into the lunar cycle again, gravitational cycle in 1530 to 1605. And then when we came out of that cycle, back to global cooling. And that was the last cycle. And this is the cycle we're in now. About 1927, we came into that cycle. It started to get really cold in 2040s. And we're coming over to here. This is about the year 2024. And we're coming out of that cycle where the moon is going up to higher declination. And that's the first stage of global cooling in 2024. Second stage will be 2030, when the Atlantic goes below normal water temperatures, along with the Pacific. So just a quick look at the cycles. A 1,200-year cycle of the gravitational cycles, electromagnetic. We can see the 220-year cycles, 240, 240, 230. And we overlay it onto the global warming cycles, and we see a match. Look at that. Cycle number 2, number 3, 4, 5, and 6, and we're coming out of that now. Now, we're going to end up here with the concentration of atmospheric gases. About 99% of the population of Earth do not know about this. Instead, they say, did the increase in CO2 since 1850 cause global warming? That's what we're told. Well, let's take a look at the atmospheric gases, percentage of gases. And on this graphic, we see a big red on the left. Gee, that must be carbon dioxide, right? I know people that go around talking to other people. They've seen my PowerPoints. And most people, when quizzed, they say, oh, the percent of carbon dioxide in the atmosphere is anywhere from 20 to 70% of the atmospheric gases. Okay, let's take a look at it. One on the left, 78% of the atmosphere, parts per million, is nitrogen. I bet you didn't know that. Oxygen is 21%. Well, okay, this next one must be the carbon dioxide. No, 0.9%, that's argon. Well, that's 99.99% of the dry air. So where's carbon dioxide? Well, we do have variable greenhouse gases. So variable greenhouse gases, okay, this must be the red line here for carbon dioxide. Sorry, it's water vapor. 1 to 4% of the atmospheric gases is water vapor. It can be 0% up in the Arctic, high Arctic, and up to 4% in some areas, average of about 2%. Okay, so where's carbon dioxide in the greenhouse gas? Less than 0.04%. Drops down to 180 parts per million during glacial periods and up to about 420 parts per million during our warm interglacial periods. And as a summary of that, water vapor is about average of 20 parts per million, which is 2% of the atmospheric gases. Natural carbon dioxide, 380 parts per million, not very high, 0.04%. Then we get the burning of fossil fuel. Only 35 parts per million. That's 0.004%, 4 1,000ths of 1%. Far too little to cause global warming. It is natural cycles that cause it, the climate pulse. And this is what happens on it. On our climate, we're going to go back 450,000 years ago. This is from ice core data. The red line is temperature. You can see 450,000 years ago, we came out of a glacial period, warmed up greatly, and so did the carbon dioxide. It was released from the oceans. And then we cooled down greatly into an ice age, and the colder oceans absorbed the carbon dioxide. Then again, we warmed up greatly, way back 338,000 years ago. Carbon dioxide was released from the oceans again, but didn't peak until several thousand years after the temperatures peaked. So this happened right across time, and here we are right now. We're supposed to be warm. We're in a warm interglacial period, 420 parts per million. However, a lot of scientists say, or everyone says, yeah, but we've never been above 300 parts per million before, because look at this, my ice core samples, this is 287 parts per million, 278, 298, 280. So 420, that has to be, most of that, the increase of that must be from carbon dioxide. Well, this is what NOAA says. Increase in carbon dioxide in the atmosphere since 1850 is 100% due to fossil fuel. Well, on my podcast, I show 3 different research items. One is I researched one and shows that it increases 80% natural, only 20% fossil fuel. Another great scientific peer-reviewed paper by Scrabble et al. This is in our podcast number 64. They also say 80% natural. And plant stomata, which is a great scientific study, also 80% natural. It's only 20% increase due to fossil fuel. And you can get those on Tom Nelson podcast interviews with me, number 64, 97, 73, and I'm not sure what this one's going to be, but this one will be coming out now in mid-May or so. And you can get that on Tom Nelson's podcast, or I will have them on www.globalweatheroscillations.com and globalweathercycles.com. And again, as we gather our thoughts, as you can see, use common sense, not political science. 6 global warming cycles. And no one talks about the other 5, only number 6. Use common sense. The last global cooling cycle began in 1825. And what happens is, I'm going to go back to number 1. When that cycle, let me put that back. When that cycle ended at 900 AD, the next one ended 200 years later. Then the next one, global warming cycle, was 240 years later when it ended. Then 200 years later, 230. So they alternate between 200 to about 240. So this current one should alternate back to 200 years for its ending. And the last one began in 1825. We had 200 years to that. We get 2024 to 2025. Global cooling is beginning. Well, thank you, Tom, for having me on today.
All right. Thank you very much. Do you have time for a question or two?
Sure do.
Very good. I would just like to try to get a handle as to the magnitude and the timing of cooling that may be coming. Like over the next 10 years or so, do you see that there would be enough cooling coming that they couldn't fudge the data? And I'm worried that they're going to fudge the data and make us think it's still warming when it is cooling. Will they be able to do that, or will it be obvious that it's cooling?
Well, that's going to begin the latter part of this year as the Pacific Ocean cools down, this year to next year. At that point, they won't be able to add in the Pacific water temperatures and say it's, the 5th warmest year on record or anything like that, because that's a big area of the world. And then by 2030, when the Atlantic Ocean is down to at least normal temperature by 2030, then dips below normal. So I'm saying by 2031 to 2030, somewhere in there, if they use the same formulas, adding in the ocean water temperatures, global warming is gone by that time. Now, the land temperatures, we're seeing the high Arctic cooling down. So this will be a gradual process to cool down the Arctic and then filter it to the mid-latitudes. So we have to remember, global warming came on kind of gradual. It started to warm, 1980s, 90s, especially after year 2000, it started to warm a lot. Then it hit its pinnacle in 2023. When you hit a pinnacle, there's only one direction to go after that. That's down. So 2023 is going to be the last time it's the warmest year on record. That's it. It's gone. Because the El Nino is coming in now, and that's going to cool down quite a bit of the Pacific Ocean from, June right through the rest of the year. So that's done. That's done. So this is what we're seeing. Global warming will be dead by 2030, but will be, as I said, gradually cooling down. It took about 23 years to hit the pinnacle for warmth. Well, it's probably going to take 20 years to hit the real bottom of the global cooling. So somewhere around the mid-2030s, it'll really be getting colder, but the coldest weather is going to be in the 2040s, 2050s.
Okay. Do you have any thoughts on what's happening with this giant solar storm we're hearing about, that, or about the Earth's magnetic field potentially flipping, either one of those things?
Well, I think on the solar storm, what we're seeing is, as I indicated, the solar insolation cycle, which is the solar cycles, they go up and down on a 1 to 2 year cycle, but it's more like a longer cycle for the whole thing. So I think we've had a brief peak in the solar cycle right now, and that's why we're getting the storms we're talking about. And that's the pinnacle, probably. And it's going to be going down, the solar insolation right after this. That's a indicator, I believe it. Okay, from there, it's only down.
Okay, and then anything on the magnetic field reversing on Earth potentially?
I think has to be a little bit long term. You don't want to jump on. I don't like jumping on a lot of this stuff because we've never had instruments on site to record most of this stuff. So a lot of it's guesswork. So we have to kind of piece things together, and we just hear so many scare tactics out there, just a lot of scare tactics. And that's all pretty much tied to political science, a lot of it. But there will be a reversal eventually, yes.
All right. Any other points you'd like to make before we finish up here?
Well, biggest point is, that's a good point. The biggest point is, look at history. People don't know about how much carbon dioxide there is in the air, a real amount, and look at the history of it, and look at the history of cycles, global warming cycles, global cooling cycles. It's I heard someone mentioning on some program the other day, says, well, I don't know, ever since I've been on Earth, we've had warm summers. It's supposed to be warm. And I showed you that on the cycles, on the 120,000 year cycle, interglacial, we're supposed to be warm now. On the 200 year global warming cycle, we're supposed to be warm now. That is a cycle. So we have to know, you have to learn and know history to know what's going on now and what's going to happen in the future. If you eliminate history, you won't know what's going on. And this is what they're trying to do, is eliminate history by telling you, well, we only show the weather data going back to 1850. We don't want you to know about the other global warming cycles. We've never had any. And that's not right. So this is the problem. We're eliminating history and a lot of things. History of the United States, of the world, not just the climate, just eliminating history so they can have control.
All right. On that note, thank you very much for taking the time to do this, and I'll get it put online soon. Thank you very much, David Dilley.
Thank you.